So how does this thing perform, right? So ESG, Enterprise Storage Solutions, they ran a study with the IOZone benchmark. They fired this up on Google using Google Compute. So there are 124 cores that they fired up, ran it against a 2 petabyte file system, all connected using the NFS v3 protocol. And they put the offering through its paces. And here's the performance that they reported. It's 200 gigabytes per second on the read throughput. It was 120 gigabytes per second on the write. It's not shown on this graphic, but that's what they hit. And these are game-changing kinds of numbers. And to give you a sense of how it stacks up with another NAS vendor that's offering file services in Google. I mean, for the read throughput, it's 46 times higher. For write, it's 96 times higher. And then, we've talked about the capacity a number of times. It starts at around 100 terabytes, scales on up to 50 petabytes, which is 500 times the max capacity of our nearest competitor in this space. So the scale is there for performance and capacity. ESG ran another benchmark. They use Scratch DNA, and this is pretty popular in the life sciences space when they want to get a sense of how well the storage is going to keep up with their sequencing. And that was, it's write intensive as they're, concatenating strings in these files, and they can be small to large files to represent a DNA strand. And it came in at 110 gigabytes per second. So that's to give you a sense of the performance and the scale and the PowerScale that we're bringing. And and it's an aptly named product from that standpoint. We're bringing that PowerScale that we have on-prem, we're bringing it to the cloud in such a way that you get in the same level of performance in the cloud as you do on-prem. One thing we didn't talk about was the latency here. And, the way we implement something like this is, it's our hardware, it's our software. It's running co-located with a high bandwidth network connected directly into Google's cloud with very low latency of sub-millisecond latencies. So we can enable these high performance compute workloads. And just a little, under the hood, we talked about, yes, this is our hardware. Under the covers, it's a Isilon PowerScale cluster under there. The customer benefit is, well, they're not the ones deploying the cluster. They're not the ones managing the cluster. They're not the ones dealing with software upgrades or configuring the network to make it happen. They go to that Google portal, they click some buttons, and they get it as a result. And it's all managed and operated by us at Dell Technologies. What the end users see is they see the file system, right? They'll see a cluster, and they can manage, create the file shares and provision them themselves, and pick the protocols that they want to use for their applications. Which then takes us to the user experience. So just to give you a sense of the look and feel of the product, we're going to give you a little demo. So yes, it is integrated directly into the Google portal. We partner closely with Google to make that happen. It's also tied directly into Google's billing system. So the customers get a single bill from Google, whether it's for Google's compute and other services or our storage. And we can now, I just want to pop into just a brief demo so you can see what that looks like.
Joe, while you're setting that up, can I ask you a quick question about the positioning about using co-located rather than running natively within Google?
Yeah.
Now imagine two scenarios. One, you run as your model where you're co-located and therefore you're outside of the network in terms of egress, and that's obviously got significant benefits. But at the same time, you're going to have to deploy equipment into locations physically to match where customers are going to want to deploy equipment, and you're going to have to put equipment in to scale. So you're going to have to scale alongside that. What we've seen a lot of already in the last couple of days is when we talk about PowerScale, we've been told that it's been very much modified to run in generic hardware. So theoretically, it could run in VMs, and it makes me wonder why, if you're partnering with Google, you couldn't partner with them to run this as a native VM rather than have to co-locate it, other than perhaps the networking challenge.
Well, the network challenge is a big part of it, right? Yeah, I mean, granted, there are solutions out there. There are virtual storage appliances that you can spin up and and you can run in the cloud. But we've been thinking about this more holistically, in the sense of even for a virtual storage appliance running in the cloud, it's still a virtual appliance and it's still administered by the end user. So for one thing, we wanted to take the user administration out of it.
Okay, hold on a second. Sorry, I wasn't meaning that the user would actually do this. I was meaning that rather than you deploy physical infrastructure on which you run this close to the environment, you deploy on Google hardware that effectively gives you the same scenario. So you do exactly as you're doing now. You manage it. You manage it for the customer. Customer gets the look and feel through the interface and everything you're going to show us. But rather than it physically have to be a physical server sitting in a colo, it's either a VM or a physical box that Google has provided for you in that location. So you're using their infrastructure in order to support your technology.
Yeah, no, it's a fair question, and I get what you're going for there. Theoretically, we could do that. What I would say what holds us back from doing that, at least in the context of Google, is to deliver the kind of economics we want to deliver for the customer. It's actually more cost effective to do it the way we're doing it with hardware than it is to go virtualized, because that would mean our nodes would have to be a lot smaller, which means you would need a lot more of them to kind of hit the kind of capacities that our customers want and the kind of performance levels they want. This is a to take the kind of performance numbers to really bring the value of the platform to bear at a cost, at an economics cost that customers want to pay. Right now, this is the best solution.
Okay, all right. So I'll finish the last question, sorry, and then I'll let you get on with the demo. That sort of implies to me that the physical hardware that Google is running on couldn't be repurposed to be useful for you to run your application.
It would imply that.
Sorry, say it again?
It would imply that.
Okay, so right, there you go then. That's all I need to say. I'll shut up.
All right, so this is a quick demo, and again, it's just to give you a sense of the customer experience. Right?
So just to follow up on Chris's question, so which regions are supported with PowerScale in the cloud?
Yeah, today with Google, it's we're in Ashburn, and we're in Sydney, and we're in Singapore, and we're expanding. We would be expanding based on customer demand.
Okay.
So here's our Google portal, and we can go to the dashboard here, and we will find PowerScale down below, and we're going to create a cluster. And here's where you name your cluster, you choose your region, here's your tier, your performance tier that you choose. You choose the size of your cluster, so go for 603 terabytes, and then you plug in the IP range for that cluster. And then create it. All right, so once that cluster is created, you can go into it and you can start to provision your file shares. So we're going to add a share. And we'll name it. This will be an NFS share. And we'll choose the NFS v3 protocol. Choose our capacity, create a share. So this is the user experience, right? This is what provision looks like to the customer. And we'll just add one more share. Well, first we'll click here. We'll take a look at the mount instructions. You could just take that and cut and paste it. Now we'll create another share. This will be multi-protocol. So we'll do NFS v3 and SMB together and choose a capacity. All right, then we have our second share created, and we can look at the mount instructions for that as well. There they are. You just take that, plug it into your host, mount it, and then you'll see all the network capacity in I/O operations right there. So that was a quick one, but
so it's effectively, this solution is equivalent to PowerScale as it exists today? I mean, I didn't see HDFS. I'm not sure if that's even useful in this sort of environment, but my understanding was HDFS is a supported protocol for PowerScale.
Yeah, HDFS is available at the customers today. We just didn't get it into the GUI yet.
Oh, okay.
So,
But so
actually, we have quite a few customers who are interested in using this for their, kind of Hadoop kind of workloads.
yeah. So I mean, so it is functionally equivalent. It is Isilon equivalent then, or PowerScale functionality equivalent. It's not like it's down level from that or anything like that.
It is not down level.
Okay, thanks.
Yeah. All right. So PowerScale for Google Cloud, we walked through. It's got awesome capacity. It's got awesome performance. It's got enterprise grade features with native replication and snapshots, multi-protocol, NFS, SMB, HDFS. We couldn't do an event like this without giving you a little bit of an announcement. So, for the next protocol that we'll be adding shortly is going to be S3. And if you were paying attention during the PowerScale presentation, you see that S3 is already natively in PowerScale today at launch. We haven't brought it to our cloud service yet, but we will be. And this is largely for customers that, I think, Enrico, you were the one that was saying, well, customers want object. Well, they do. They want the object protocol. They want S3 along with their file. And especially as they take applications and if they are transforming them to become more cloud native kinds of applications and want to move to an object model, we're enabling this kind of transition for the customer. Whether they access the data from NFS or from S3, it's the same data. So you don't, as you evolve your applications, you don't have to move the data or transform the data. You just have to change the protocol. So S3 will be adding that to our service as well.
So what about something like Data IQ? Does it cover the GCP solution as well?
Yes.
So you can use that to manage file sprawl and that sort of thing.
You can use Data IQ. Yeah, I mean, at its core, I mean, it's meant to be able to catalog data across environments and across your systems, whether it's ours or third party. And yes, absolutely, we support it for Google Cloud. All right. So storage for multi-cloud. So we spent a lot of time here talking about the left-hand side of the picture here, the PowerScale native offering for Google Cloud. As Geeta mentioned, this is our first native cloud offering that we brought to market. In addition to that, we have storage for multi-cloud, which we offer any of our arrays as whether it's a PowerMax or PowerStore or PowerScale as a service connected to the cloud of your choice. We do work with a partner, a service provider. Our partners over at Faction. We work really closely with them to bring the solution to market. And these are for customers that they don't want to be tied to any particular cloud provider. They want their data to be independent of that. They can serve that data to to applications that they have running in, say, Azure or in Amazon, or even simultaneously, right, to get to that multi-cloud. And of course, with an offering like this, you have no egress fees for the offering. So you guys might have heard of this one before. We actually launched this one about a year ago. So that's in the market. And since then, with Microsoft, we made some advancements optimizing the solution. When you talk about egress, especially when you talk about solutions that are co-located, there's really two forms of egress. And if you look at the diagram here, there's the east-west form from going from, say, the colo to your data center, an ingress on the way back. No egress there for any of these solutions. It's the one that goes north-southbound, well, specifically southbound, as you're doing write operations to the data that leaves the cloud. Well, that's egress too. And here we've optimized that where you have zero egress for that as well. So zero, whether it's northbound, north-south, or east-westbound, zero egress costs. That was an optimization that we've recently brought to market, working in partnership with Faction and as well as with Microsoft. I should also point out with our Google PowerScale for Google, there's also no operation egress fees.